In this video, we're going to look at how we can write our angle theta as a function of x given a right triangle. So if we look at the given problem, we have a right triangle, we have our angle theta, and we know this side is 4 and the side up here is equal to x. And if you're asked to write theta as a function of x, that means that we want to come up with an equation where we have theta is equal to some expression here to represent the angle. So in order to do that, we're going to use our trig functions. And of course, you can think that we just talked about inverse trig functions, and we said that if you're using an inverse trig function, that means that you're looking for the angle. So we're going to end up using an inverse trig function to write theta as a function of x. So let's kind of review here. If we have what side? We have our angle, theta, and then this side here would be our adjacent side, and we have the hypotenuse. So if we want to write theta as a function of x, then what trig function is adjacent over hypotenuse? And that would be the cosine. So the cosine of our angle theta would be equal to the adjacent side, which is 4, over the hypotenuse, which is x. Now, this says the cosine of theta is equal to 4 over x. But we want to write this so that we can solve the equation for theta. So we want to have theta equals, okay? So to get rid of the cosine, when we say the cosine of theta is equal to 4 over x, then that means we can actually take the inverse cosine of 4 over x, and that would find the angle. So in a sense here, what we're doing is we're taking the inverse cosine of both sides of the equation, okay? So here we're solving for the angle theta. So the inverse cosine of theta, that's going to cancel out and we're left with the angle. So therefore we have theta would be equal to the inverse cosine of 4 over x. Let's try another example. Let's say that we have the following right triangle. Here's our angle theta. And we have this side is 10, and this side over here is x plus 1. And at this point, you may want to try to pause the video and see if you can come up with theta as a function of x. So here, first of all, what I would suggest is identify the sides. Well, once again here we have the adjacent side. The x plus 1 is the opposite side. So we ask ourselves, what trig function has the adjacent and opposite side? And hopefully we can remember that would be the tangent. So that means if the tangent of our angle theta is equal to the opposite, which is x plus 1, over the adjacent, which is 10. So then if we want to solve the equation for theta, if the tangent of the angle is x plus 1 over 10, then that means that the angle is going to be equal to the inverse tangent of x plus 1 over 10. So here we have our angle theta as a function of x. Okay, let's look at one final example. Here we have our right triangle. Here we have our angle. We have x squared minus 1 and x minus 1. So once again, we need to identify what's given. Well, here's the angle. We have the adjacent side once again, and we once again have the opposite side. So at this point, you probably guessed we're going to use the tangent. And we know the tangent is opposite, so that would be x minus 1 over the adjacent, which is x squared minus 1. So again, that means the angle theta is equal to the inverse tangent of x minus 1 over x squared minus 1. Now if you look closely here, we can simplify this a little bit. If we look at this inverse tangent here, we have x minus 1 over x squared minus 1. Well, x squared minus 1 is a difference of squares, so we could factor this to x minus 1 and x plus 1. And if we do that, we'll notice that the x minus 1 will cancel the x minus 1 on the bottom, so we can simplify the equation to the inverse tangent of 1 over x plus 1. So once again, we have solved our angle theta as a function of x.